All right, so we've done 2 lessons on methods to solve quadratic equations. We've learned about square roots and we've learned about factoring. So today we're going to talk about, well, how do you choose which method to use? Which one of those is the best method for each given problem? So our warm-up really is a good way to just kind of remember the 2 methods, and it kind of gets you started on that idea of which one is the best method. So here's our problem, right? X plus 3 in parentheses squared equals 25. And the question says, can you solve this in more than one way? So if you want to, you could pause your video and see if you could at least just solve it in one way. And if you can come up with 2 ways, that would be great. So probably after yesterday's lesson when we were talking about factoring, the first thing that would probably come into your head is maybe I would want to multiply out this x plus 3, this binomial squared, and then use factoring. That could be one method, right? So factoring would be one way. But in order to do that, we'd have to do quite a bit of work. And that would start by taking this x plus 3 in parentheses and squaring it. Now remember, when we have a plus sign inside our parentheses, I cannot just distribute that exponent because this is a binomial. So you could use the bin squared shortcut, or you could write them next to each other, right? X plus 3 squared really means x plus 3 times x plus 3, right? And I know that this is supposed to equal 25. Now remember, I can't use finding the zeros unless it equals 0, so I'm not ready yet. First, I would have to actually multiply this out. So I'd get x squared plus 3x plus 3x plus 9 equals 25. I'd have to combine some like terms here, right? So I'd get x squared plus 6x plus 9. Now, if you use the bin squared shortcut, you could skip that green step. But many of us don't always remember that bin squared shortcut, so I did it the long way, and that's fine. But now remember, it still doesn't equal 0. In order to use factoring, it has to equal 0 first, right? It's got to be in standard form. Ax squared plus bx plus c equals 0. So I need to subtract the 25 before I can do any solving, right? Or I should say any factoring. So I get x squared plus 6x minus 16 equals 0. All right, so now let's see. X squared plus 6x minus 16. What are the factors of 16? Oh, how about 8 and 2? Now, I could use a factor box, right? So I could use a factor box and set all that up. I'm a little bit short on space here. So if you use the factor box, you'd end up with your parentheses to be x plus 8 and x minus 2, right? Because I'd have my outsides would be negative 2x, my insides would be positive 8x. When I add them up, I would get positive 6x. So x plus 8 and x minus 2 would be my 2 sets of parentheses. And then I take each set of parentheses like we learned yesterday, and I make each one equal 0. So I have x plus 8 equals 0. And then I subtract 8 from both sides, and I get x equals negative 8 as one of my solutions. And then I go to my other parentheses, and I set x minus 2 equal to 0. And I add 2 to both sides, and I get x equals positive 2 as my other answer, right? Now, that was quite a bit of work, but I'm sure that one was maybe the one that popped into your head first, because that's what we just did yesterday. But let's think about square roots, right? That was our other method of solving with square roots. Now, if we remember, if I'm using a square root, I'm trying to get whatever is squared by itself, right? Hang on. X plus 3 is in parentheses squared. That is by itself. So if I'm just going to copy that part right over here, I have x plus 3 squared equals 25. It's already by itself. So all I have to do, I could just start first thing with taking the square root of both sides. Square root and squared cancel on this side, so I get x plus 3. And then the only thing you can't forget, right, when I write the square root sign in order to solve an equation, my answer, let's see, square root of 25 could be positive 5 or it could be -5. So don't forget your plus or minus. I know you were great at remembering it on day one. That was the first thing we learned, and you did a really good job with your plus and your minus. But, then we do another method, and then you start to forget. So don't forget plus or minus. When you write the square root, the next step needs a plus or minus. And now I just have to move that 3. So I'm going to subtract 3 from both of my options here, right? So I get x equals 5 minus 3 is +2. -5 minus 3 is -8. And look at that, I got the same exact answers. Now, take a look at those two methods. Which one was the better choice for this problem? Square roots, right? Way less work. So the idea today is not that only one method will ever work for a certain problem. They probably would both work, well, yes or no. But sometimes one method is way faster than the other. And I will say, most often, if you can use a square root will be much less work. So that's kind of our problems that we're going to go through today is how do we decide which ones can I use a square root on and which ones do I need to use factoring on? That's the big idea. Okay, so here's our two problems, and it says, which method would you use to solve these equations? Now, I kind of want you to look at both of them. I'll give you a hint that you can use one method would be for one of them and one method for the other. So one of these is a square roots problem, and one of them is a factoring problem. And really analyze, take a look. They look very similar, but one of them you can use a square root on, and one of them you can't. So if I look at number 1, it says x squared plus 10 equals 59. If you analyze that really carefully, I see that I have an x squared, but then I just have a plain 10 and a plain 59. If you notice in this one, there is no x term, right? There's an x squared, so I know it's a quadratic equation, but there's no x term. If I look over here on this next one, I notice I have x squared plus 10x equals -16, right? Now, a lot of times when I say like, oh, can I use a square root here? This -16 kind of throws us off, and that's a good thing to point out, right? Is that I can't take a square root of a negative number, so that might be a danger zone, but my x squared isn't by itself, so don't just judge that just yet. But the big thing here is I have an x term in number 2, so if I was going to use the square root, I couldn't take the square root of x, right? And I can't ever divide by x like we talked about yesterday. So number 2, I would have to use factoring. Because, oops, that's supposed to be an exclamation point. I have to use factoring on number 2 because there is an x term, right? Now on number 1, there's no x term. That means I can use a square root on this one. I can get that x squared by itself, and that's the only x in the whole problem. So once I get that x squared by itself, then I can take the square root of both sides. But on number 2, if I tried to get x squared by itself, I'd still have an x then on the other side, and that'd be a big problem. All right, now we could practice this and make sure that we can solve it, but the big idea is knowing which method to use when, right? So now if I'm going to use square roots, remember then the next step is that I need to get the x squared by itself. And don't forget your plus or minus. So the process for using a square root, once you figure out that you can, right, if there's no x term, then the next steps are to get the x squared by itself. So I want to move that 10 to the other side. So I get x squared equals 49. And once that x squared is by itself, I can take the square root of both sides. Squared and square root cancel, so I get x equals, now don't forget, I wrote the square root sign in order to solve my equation. Square root of 49 is +7 or -7, right? So don't forget plus or minus, right? So that's the big idea with square roots. That's the only tricky part is you got to remember your plus or minus. Otherwise, way faster. Okay, now number 2, we decided we had to use factoring because there's this plain x term in it, right? So if I have my plain x term, and so I use my factoring, that means that I need to get it into standard form, right? So get standard form, which means ax squared plus bx plus c equals 0, right? So I got to really make sure that I get it to equal 0. That's the big idea. So my first step on this one would be to add 16 to both sides. Now I notice there's no other like terms, right? So it'll become x squared plus 10x plus 16 equals 0. And remember, I want to make sure I put it in the right order, standard form. X squared's first, then x's, then plain numbers. And the big idea here is that it equals 0, right? Okay, now here, again, you could do it in your head if you know it, or we can use our factor box. I will actually show the factor box on this one because I have enough room. So I put x squared above the first one, right? I'd put 16 above the last one, and my 10x would come down into the middle. All right, so it must be x and x. Let's see, what multiplies to give me 16 and adds up to 10? Ooh, it's a positive 16 this time. So it must be positive 8 and positive 2. Let's see, 8x plus 2x does give me 10x. So my parentheses again are my diagonals here. So I have x plus 2 and I have x plus 8. And again, that you maybe could do that without the factor box, and that's perfectly fine. You don't have to use the factor box here if you can do it without. But just to make sure, don't forget to bring down that equals 0, right? We're not done when we use our factor box this time. We need to make sure that we keep going, and in order to keep going, we have to have our equals sign in our equation. So now after I have my factors, then I take each factor, so I have x plus 8, and I make that little mini equation, set it equal to 0. I would subtract 8 from both sides, and I get x equals negative 8 as my first answer. And on the other side, I take that x plus 2 and make it equal to 0, and then I subtract 2 from both sides, and I get x equals negative 2. So those are my 2 answers there. All right, so good refresher on our 2 methods, right? But the big idea is to figure out which one is the most efficient. So I made this nice little chart, which I think would be a great thing to add to your notes. I know you probably have to pause your video a little bit to write it down, but this chart would be excellent to have in your notes. So the question is, how do I figure out which method to use? And the big question up at the top, does it have an x term, right? And by an x term, right, the term with a plain x. Okay. So if the answer is no, it doesn't have a plain x term, then I want to solve it with square roots. If I'm solving with square roots, I want to get the x squared by itself. I've, solve the process, get the x squared by itself, take the square root, but after you take the square root, don't forget the plus or minus. If you have an x term, right, does it have an x term? And the answer is yes, then you have to use factoring. Right, so make sure then the first step in solving by factoring is to get the equation to equal 0, or in other words, put it into standard form. And again, remember, standard form is ax squared plus bx plus c equals 0, right? That's what standard form is. Now, we just did a factor box, right? We knew right away that's how we were going to factor it. But sometimes, like we learned yesterday, factoring, we have lots of methods to factor. So the big idea is look for how many terms are there, right? Now, the 3 terms is the one that we just did. It had 3 terms. So that was really obvious that I was going to use my factor box, right? But don't forget for those 3 term ones that you could look for a GCF. Right? Always look for that GCF first. And you could also use a bin squared shortcut like we kind of talked about in the warm-up. But by all means, you may use that if you remember it. But the big one for 3 terms is usually the factor box. If it has 2 terms, that's when we're looking for definitely a GCF, right? GCF big time. But also don't forget about dots that could be in there as well, right? The a plus b and a minus b, so a squared minus b squared. it's in there, right? But the biggest, most common one when I have two terms will be GCF. Okay, hopefully that was kind of a good refresher of the last 2 days, and hopefully this chart will really help you. Like, this would be something to go back to when you're really trying to decide which method should I use, and that's the name of the game for today. All right, so here we go. I'm going to zoom in a little bit, and we're just going to do one at a time. So this time it does say solve the equations with the most efficient method. So step one is to figure out what that method is, and then after that we're going to solve. So it's going to be a good refresher and practice of the last 2 days. So here's our first one, 3x squared plus x equals 6x plus 2. So the big question right at the top of our chart was, does it have an x term? And the answer is, sure does. So this would be solving by factoring. So remember the process for solving by factoring then. First step is to put it into standard form. So I am going to subtract, I have my 3x squared over here on the left, so I'm going to move everything to the left. So I'm going to subtract 6x. I notice that it does have a like term here, so it's going to line up with that plain x, and then I'm going to subtract 2, and there isn't a like term for the minus 2, so that's just going to be at the end. So my standard form will be 3x squared. X minus 6x is minus 5x, and then I have my negative 2 at the end, right? And now it's going to equal 0 because I've moved everything away over there. Okay, 3x squared minus 5x minus 2. I see it has 3 terms, which means I'm going to be using my factor box. Now this is, or just, getting those two binomials. Again, if you can do this without the factor box, more power to you. Go for it. But I'm going to use a factor box on this one, especially because there's that number in front of the x squared. So I've got 3x squared up top. I'm going to have negative 2 up top. And my minus 5x is going to come down in the nook. So let's see. What multiplies together to give 3x squared? Must be 3x times x. Ooh, factors of negative 2. Well, there's not a lot. 2 and 1, right? Okay, let's see. I need one of them to be negative. I'm trying to add up to negative 5x, so it must be negative 2 and positive 1. When I multiply across here, 3x times negative 2 gives me negative 6x. X times 1 gives me positive 1x. Negative 6x plus 1x gives me negative 5x, so it does work. All right, so my parentheses, again, are my diagonals. So the first one will be 3x plus 1. And my second one will be the other diagonal, which is x minus 2. All right. Now, I take each one of my mini little equations here and set them equal to 0. 3x plus 1 equals 0. Ooh, this one's going to take a little bit of work. Let's see. I'm going to subtract 1 from both sides. I get 3x equals negative 1. And then I divide both sides by 3. And I get x equals negative 1/3. Remember, fractions are okay. And if you use, show your work, it should be staring you right there. Don't ever give me a decimal for 1/3, right? No way, Jose. So make sure that you write it as a fraction there. Okay, now I have my second one. Can't forget that one. So I have x minus 2 equals 0. And then I just add 2 to both sides. And I get x equals 2. So my two solutions here are negative 1/3 and positive 2. All right, let's look at this next one then. Number 4, 3x squared plus 6 equals 21. So the big question, right, what method am I going to use? I look carefully. Is there an x term? Oh, there's not. All I have is x squared. So there's no x term, which means I am going to use square roots. Hooray, that means this one's a little bit shorter. I just can't forget my plus or minus once I get to that step, right? So the big idea here is I'm going to get the x squared by itself. So I subtract 6 from both sides. I get 3x squared equals 15. Divide both sides by 3. And I get x squared equals 5. All right, I've got my x squared by itself, so I'm going to square root both sides. Square root and squared cancel, so I get x equals square root of 5. 5 is not a perfect square. but that's okay, right? We talked about that on day 1. So my answer is just going to be positive square root of 5 or negative square root of 5, right? I can still have plus or minus even if I have radicals in my answer. There we go. Oh man, I love the square root ones, right? All right, here we go. Number 5. 10x squared plus 2 equals negative 102. At any point here, when you're starting to feel confident, you just pause your video, see if you can do it on your own. You can always skip past my explanations if you get it right, okay? All right, let's see. Is there an x term? There is not. So this one, again, would be square roots. Hooray. So we're going to get that x squared by itself. So let's see. First step, minus 2. So I get 10x squared equals negative 100. Excuse me, sorry, negative 104. All right, now I'm going to divide both sides by 10. I get x squared equals negative, Now, I'm sure what you guys wanted to say is negative 10.4. I definitely wouldn't do a decimal when I am dealing with squared, like x squares, right? Square roots, decimals and square roots, yuck. So I might just say I'm going to reduce this fraction a little bit and say this is negative 52 over 5. All right? Now, don't panic just yet. However, oh man, x squared equals a negative number. Yikes. That's a problem, right? The fraction wasn't the problem, but the negative was the problem, right? I cannot take the square root of a negative number. Don't forget, as soon as I get to that point, I say x squared equals a negative number. Yikes. This is a no solution. So watch out for those, okay? Don't forget about them. Okay, so we got that one. Now let's look over here at number 6. I've got 6x squared equals 24 minus 18x. So big question is there a plain x term? There is this time. Negative 18x, right? So this one has to be solved with factoring. So again, when I'm going for factoring, that means I need to get it into standard form. Now, I always want that x squared term to be positive, right? So my 6x squared is on the left, which means I'm going to move the other two terms that direction. So I'm going to add 18x. I see that there's no like terms with that. And I'm going to subtract 24. You get the idea. There's no like terms with that, right? So I'm going to have 6x squared, and then the plus 18x. And then the minus 24, and that's going to equal 0 now, right? Because I moved everything off over to the left, so nothing left on the right, but make sure it says equals 0. Now, 3 terms, I'm thinking a factor box. Ooh, but don't forget, first thing I looked for, and I noticed this has a GCF. I have a GCF of 6. I'm going to pull that GCF out. Now, do you have to take the GCF out? The answer is no. You really don't have to, because you can do a factor box, but it's going to make your factor box so much easier, and it's going to go so much faster if you take that GCF out, right? So I'm going to have that 6 out in front, 6 times, let's see, I have, in my first term here, I would have x squared, and then plus 3x minus 4. And I still have my equal 0, right? Because I still need to solve this. Now, this is a tricky one. You know, a lot of times when we have a GCF, the question is, can I just divide both sides by 6? And at this point, the answer is yes, you can, right? Or you can think of it as a separate factor. And then I would take 6 and I would say, okay, I would make my little mini equation, right? 6 equals 0. Does 6 ever equal 0? The answer is no, it doesn't, right? And then I would work on this next part where it would say x squared plus 3x minus 4 equals 0, and I would continue factoring. So you can either think of it as dividing, or you can think of it as, okay, I'm going to set it equal to 0. I kind of like to think of it as setting it equal to 0 so that you don't forget on those GCF ones where there's an x in your GCF. then you can't divide by x, and so that becomes a problem. So I like to think of it as setting it equal to 0, and then it's never going to equal 0, so I just keep going, right? So I cross it off. Okay, so now I have just my trinomial x squared plus 3x minus 4 equals 0. This would be our factor box. Now, if you're getting really good at those factor boxes, this would definitely be one that maybe you don't need a factor box for. You could do this one in your head, and that's perfectly fine. But if you need it, it would be x squared up top here, negative 4 up top, 3x down in the nook. So it would have to be x times x, multiply to give me negative 4, add to give me positive 3. This must be positive 4 and negative 1. If I multiply across them, that would give me positive 4x plus negative 1x gives me positive 3x. So my parentheses are x minus 1 and x plus 4. And bring down my equals 0, right? Now I make my two little mini equations here. First one is x minus 1 equals 0, add 1 to both sides, so I get x equals 1. And then I have my second little mini equation, x plus 4 equals 0. I subtract 4 from both sides, and I get x equals negative 4. All right, so again, those factoring ones take a little bit longer, right? But we got to do it whenever there's that plain x term. All right, I got 2 left for you, and that's it. Number 7, 6x squared equals 10x. This is a much shorter one. Interesting. But again, the same question still there. Is there a plain x term? And the answer is yes, there is a plain x term. So I have to do factoring on this one. Remember, I can't take the square root of x. I can't divide by x, or I lose answers. So I have to do factoring. And the next step in factoring is to get it into standard form. So step 1, I need to subtract 10x from both sides so I can get it to equal 0, right? So it'll be 6x squared minus 10x equals 0, because those are not like terms, and I got to get it in the right order. Now, here's the only thing, though. This is only 2 terms, right? This is what I was talking about in our chart. There's only 2 terms on the left, which means that if I'm looking for my method and there's only 2 terms, I'm looking for either a GCF or dots, right? But most of the time, I always want to look for a GCF first. Does this have a GCF? Yes, definitely an X, right? They both have an X in common, but if I look at 6 and I look at 10, they must have a GCF of 2X. So 2x is our GCF. Okay. 2x times what? 2x times 3x minus 5. 2x times 3x is 6x squared. 2x times negative 5 is negative 10x. All right, now I have 2 factors again, right? They look a little bit different because I have a GCF. So I take my first factor, and that's 2x, and I set it equal to 0 to make my little mini equation. Now notice, do not cross this off because there's an x in there. I can solve for x. The difference with the last one was that this didn't have an x, right? It was just 6 equals 0. 6 can never equal 0. I can't solve that. But this one, has 2x equals 0. I can solve 2x, right? So I am going to divide both sides by 2. 0 divided by 2 equals 0. Box it in. That's an answer. Don't lose that answer, right? We did this yesterday, but this is the most common mistake. All right, and then I'm going to take my second little mini equation here. 3x minus 5 equals 0. I'm going to add 5 to both sides. I get 3x equals 5. And then I'm going to divide both sides by 3 to get x by itself. I get x equals 5/3. Again, no decimals here, right? Fraction. I should be staring you in the face. So I get x equals 0 and x equals 5/3. So factoring by GCF on this one, but it's still factoring, right? All right, last one here, number 8. 25x squared minus 2 equals 2. Is there an x term? There is not. It's only x squared. So this one is going to be a square roots. Hooray! So for square roots, I get that x squared by itself. So first step would be to add 2 to both sides. So I get 25x squared equals 4. Got to get that x squared by itself, so I have to divide by 25 on both sides before I do any square rooting, right? Got to get it by itself. X squared equals, oh no, 4 over 25. Now, remember, I would not ever put a decimal in a radical. No way. No decimals here. Leave it as a fraction. All right, so can I reduce this fraction, 4 over 25? No, I can't. So it's going to just stay as 4 over 25. That's okay. Watch how this works. You can do it. Don't worry. Fractions are fine. This is not a negative fraction. It's just a fraction. We can do this. X squared is by itself, so I'm going to square root both sides, right? Now, we did a whole unit on square roots, right? And we did a whole unit with square roots with fractions, so it's okay. So remember, the square root of 4 over 25 is the same thing as the square root of 4 over the square root of 25, right? What is the square root of 4? The square root of 4 is 2. What is the square root of 25? Square root of 25 is 5. You got it. The only thing is, don't forget your plus or minus, right? So the square root of 4 over 25 is positive 2/5 and negative 2/5. A plus and a minus. But you can have a fraction even with a square root. That's okay. All right, guys, I think you guys are probably pretty confident in the idea now of picking which method for each problem. Remember, the big idea is, does it have an x term? If the answer is no, use a square root. Get the x squared by itself, square root. Don't forget the plus or minus. Fractions are okay, not decimals. All right, if the answer is yes, it has an x term, then you're going to use factoring. First step is to get that equation into standard form. Get it equal to 0. And then take a careful look. How many terms are there? If there's 3 terms, look for a GCF. That'll make your factor box easier, but then use a factor box, right? Bin squared if you really remember it. Are there 2 terms? Definitely look for a GCF. Most often it's going to be just a GCF. It could possibly be dots, but really be looking for that GCF if it's 2 terms. All right, guys, you got this.